Welcome to GeoTrig. This video is on 4-7 inverse trigonometric functions. The essential question is, what are the domains of the three basic inverse trig functions? Let's begin. Here's a summary. We're going to understand inverse sine, cosine, tangent functions, and do a few other things. Let's begin. First, what is an inverse function? And this is just kind of a reminder from maybe Algebra 2. It's basically a function's inverse if no horizontal line intersects the graph of a function more than once. So horizontal is going left and right. So maybe we have a graph of a function here, and I make my table, x, y. We have some curve. I'm going to draw that curve in black. Maybe it's going like this. It's a parabola. If we have a horizontal line that we draw and it intersects it more than once, it is not a function. So for example, that graph I just drew is not a function because it intersects it twice, right there and right there. So a parabola shape would not be an inverse function because you have that U shape and you're always a horizontal line somewhere is going to cross twice. A line can have an inverse function because if you draw a linear equation just like this, if you have any horizontal line, it's always going to cross it only one time. Exponential function would have an inverse function because if you remember, exponentials kind of look like this, and any horizontal line is always going to cross it once or sometimes never at all. So that's an exponential function that's an inverse exponential function. Let's talk about finding the inverse sine function. So if you drew a horizontal line, it's going to cross the function more than once because it's periodic. It goes up and down. So you have to restrict the inverse functions to a certain domain. So for sine functions, we restrict it to a domain between -1/2 and +1/2. So you just keep this shape here. We just ignore the rest of it, and we're just talking about this domain from -1/2 to +1/2. So if we cut out that slice, here's what it looks like. You're going from -π/2 -1, and it curves all the way up to π/2 1. So that would be the inverse of the function. That's part of the function y equals sine of x. And here's the actual graph of the inverse. If you graphed it, it kind of looks like it's actually just a sideways shape of the sine wave. So let's actually find an exact value for sine of -1 square root of 3/2. So the key thing here is we have to find a value that's between -π/2 and π/2. So the way I do this when you're trying to find the inverse sine, that's like saying sine of theta equals radical 3/2, and you're finding that angle theta. And we'll do this in radians, so instead of degrees, but you could do it either way. I don't think it matters. So we have to find some angle where sine is going to be radical 3/2. And if you go back to your unit circle, and this is where memorizing that really comes in handy. So when do you have the value sine of π/3/2? On a unit circle, that happens, sine is the y values here, so that happens at two values. It happens right up here, and it happens right up here. You know, if this is that's the halvesy mark. Remember, there's like 3 lines coming out per quadrant. So the y values, the biggest y value is going to happen right there and right there. And what is the angle right here? This is going to be 60 degrees. Or another way to say that is π/6. And the angle right here is going to be 120 degrees, or it's going to be 2/3 pi. Actually, that's not π/6. That is π/3. My bad. And this is 2 π/3. So we have two possible values for that theta, but since we have to be between this domain, that actually only covers these two quadrants in the unit circle, so quadrants 1 and 4. So the only value, the exact value for this inverse sine has to be π/3. That's what I'm looking for. Not 2 π/3, π/3. So that's how you do that. You have to remember the domain. Now let's look at cosine functions. So the cosine has the same thing when you're trying to do inverse. It'll cross multiple times. So we have to restrict it to a certain domain. We restrict it to the domain between 0 and pi. So that shape right there. And it's the same idea for the sine function. So if I want to find the inverse cosine of this, again, I'm going to go back to graphing that unit circle. So if you're graphing that unit circle and you understand what that looks like, where does cosine of theta equals -1/2? When does that happen? And cosine's the x value, so when x values are negative, and that's kind of the smallest negative, it actually happens right here and right here. Remember, these like the 3 lines, and that's going to happen right there and right there. So what are the values right there? This is actually at 60 degree, not 60, 120 degrees, or 2 π/3, and this one happens at 100, let's see, that's 240 degrees, or another way to say that is 4 pi over 3. So those are the two values, but we said our domain has to be between 0 and pi. So the domain for cosines, it's only times when the y value is positive, so it's going to be between those two areas. So the only value that works is 2 pi over 3. So that's what the inverse cosine of negative 1/2 equals, 2 pi over 3. All right, let's look at tangent function. So tangent function, again, you'd have the same problem. So we're going to restrict it to a certain domain, and that's going to be between -2 and negative pi over 2 and positive pi over 2. And just a note, you can't actually have those values. That's why it's a curly bracket, not square, because they're asymptotes there. So we could do an example of the tangents. Find the inverse tangent -1, and again, I want to find tangent of theta equals -1. Where does that happen? Well, I'm going to draw the unit circle once again. It would have been really convenient if I drew these before the video. So where does tangent of -1 happen? Well, that's going to happen at two spots. That's going to happen in the second quadrant, at that point in the middle, and the third and the fourth quadrant at that point. This is like the middle angle here. I know that because you're dividing. Tangent is sine over cosine. So when those are going to happen -1. It's actually going to be +1 on the first and third quadrants. So the angle right here, this is going to be 3 pi over 4, and this is going to be 7 pi over 4. So, but the domain, again, we said last time, is between negative pi over 2 and pi over 2. That's actually the first and fourth quadrant right here. So the answer is going to be 7 pi over 4, because that's the only one that works. Okay, here's kind of a summary of those three shapes. Just, you got to know sine and tangent kind of have the same range, but tangent doesn't include the ends. And cosine is between 0 and pi. All right, compositions of functions. So what you do when you want to solve these, you do the inside, then do the outside. So first I want to find but here's some neat properties of this. So first you got to find the cosine of inverse cosine of 0.7. But the neat thing is when you find the cosine and the inverse cosine, it's just going to come out to 0.7. Because they kind of cancel each other out. But now, the neat thing, you still have to watch the domain. So the domain of the cosine, inverse cosine functions, we said was between 0 and pi. And 0.7 is between 0 and pi. But now the sine functions. So we said sine functions have to be between pi over 2 and negative pi over 2 and positive pi over 2. But so if we did sine of pi and then the inverse sine of pi, you might say, oh, okay, it's got to equal pi. Well, that doesn't work because that's not between that domain. That's going to actually come out to 0. Because sine of pi happens at two places. Sine of pi happens at 180 degrees. Right? Sine of pi is at 1, and what's sine at that point? Sine at that point is going to be 0. Because that's the y values, right? So you think sine of inverse is 0, but that's not going to be pi because it's outside of our range. The other point where it's pi, where the inverse sine is 0, is actually at 0. So that's your answer. Cosine. Now cosine and the inverse cosine, you think, okay, I could do that, it's -1.2. But that doesn't work out because -1.2 is outside of the domain. So what we actually say for this last one is -1.2 is not included in the domain, so this is undefined. You cannot find that inverse cosine of -1.2. All right, let's do some examples. So pause the video. All right, I'm going to graph that one really quick. Inverse sine of negative radical 2 over 2. So sine theta equals negative radical 2 over 2. I know that happens at two places here. That's the y values, and negative y value is going to be right here and right here. But the sine function only covers this side, so that means my inverse sine is only going to be that angle, which is at 7 pi over 4. Next one. Pause the video. All right. Inverse cosine of 1/2, so cosine of theta equals 1/2. This happens if I'm graphing my unit circle. That's the x values at 1/2. That's going to happen at right here and right here. But the cosine function is between 0 and pi, so it's only going to be this top one, and that is at 60 degrees, Or another way to say that is at pi over 3. That's it.